Do you guys like parkour, the sport of doing crazy things? Well, here's a physics question based on that that I made up, just a made-up question. So in this case, imagine that you have a person jumping from a building to a lower building separated by a distance. Maybe it's over an alley or something like that. But the height of this building is 4 meters taller than that building, but they're 3 meters apart. And so if you don't make that jump, you don't want to do that. You don't know what's down here. It could be an alligator or a dragon. I don't know what that is. But there could be water. Could be anything. So you don't want to miss. So the question is, if they jump with some initial velocity v0 at a 22-degree angle, how fast do they need to go? It's kind of a tough problem because you don't really know what you're doing necessarily, but let's just jump into it. When you have a problem like this, if you don't know what you're doing, that's fine. You just kind of start doing stuff. And if you take a path down the wrong way, well, then maybe you start over. You never know. Okay. So this is projectile motion. In projectile motion, we like to break it into two one-dimensional problems, an X motion problem and a Y motion problem. So for the and we also need to pick our origin. I'm going to pick that as my origin. So in the X direction, and then if I have some velocity v0, I'm going to need to find the initial X velocity and the initial Y velocity, and if that's the angle theta, well, I have a right triangle. I can use my vector components. So the Y velocity is going to be v0 sine theta. I'll put that in there in a little bit. And the X velocity is v0 cosine theta. So let's write down everything we know about our X motion. I know my initial X position is 0. I know my final X position is 3. Right, because I want to end up over here at X equals 3. I also know my initial X velocity, v0 vx0, is going to be v0 cosine theta. So with that, I know the acceleration is 0 in the X direction. I can write down the following kinematic equation: x0 plus v0 cosine theta times t. Right, because there's no acceleration. I know that. I know that. I know theta. I don't know time and I don't know v0, so I can't solve this equation. Well, let's go to the Y motion. So in the Y motion, what do I have? Well, what's my initial Y position? It's h, right, which is 3. So I know y0 is h. Y final down here is at 0 because of where I picked my coordinate system. The initial Y velocity is v0 sine theta. So that gives me the following kinematic equation: y0 plus v0 sine theta t minus 1/2 gt squared. Because remember, if you're in projectile motion, the acceleration in the vertical direction is negative g, where g is the gravitational field, 9.8. Okay, so I know some stuff I don't know. I don't know t. I don't know t. I don't know v0. I don't know v0. So let's put in our values and solve this one for t, and then plug it in over there. So I know x final is 3, and then initial velocity position 0. So this is just going to be v0 cosine theta t. So t is going to be equal to 3 over v0 cosine theta. Now if I take that expression and plug it in over here, and I'm going to put my numbers in too, I get 0, that's my final y, equals the initial y of 4, plus v0 sine theta times 3 over v0 cosine theta. And then I have, that was my t, and then I have minus 1/2 g, and then this squared, which I'll write as 3 squared is 9. So it's 9 over v0 squared cosine squared theta. So I only have one variable in this equation. I know my theta, I just didn't put it in. The only thing I don't know is v0. So right here, that v0 cancels. So this is a number, this is just a number, and that's a number over v0 squared. Let's just go ahead and put in numbers. So 0 equals, I'm going to go ahead and put this whole thing in as a single number. Okay, so it's going to be 4 sine of 22 divided by cosine of 22. It's tangent of 22. I'm going to do tangent of 22 times 3. So let's put it in my calculator. So I get 4, 3, and then 22 tangent times plus. So this gives me 5.21. And then this whole thing, let's get all that except for this number, v0. So I have a half times g times 9 divided by cosine squared theta. Let's just get that as a single number too. It's going to be a half times 9.8 times 9. And then I have to do 22 cosine squared divided by, and I get 51. So this is going to be minus 51.2 over v0 squared. Now we have a pretty easy equation, right? I can solve this equation. So I'm going to add this term to both sides. Am I running out of room? I can do it right here. Let's do it right here. So I get 51.2 over v0 squared equals 5.21. Now I'm going to multiply both sides by v0 squared, divide both sides by that. I get v0 squared equals 51.2 over 5.21. And then I'm going to take the square root of both sides. So let's do that. Okay, 51, so divided by 1 over square root. I get 3.14. So that's how fast I'd have to run and jump to make it. And when I say I would, I wouldn't, because I'm not going to do that. I'm not silly. Okay. So that's how fast you'd have to run and you would have to run and jump to make that gap. Of course, if you go faster, you'll make it more. Now, I don't know how wide that building is. Maybe if you go too fast, you might go too far. But and that is a pretty high distance to drop. You're gonna impact with a great speed. But we'll talk about that in another physics problem. But it seems like he could do it. That's not an unreasonable speed for a normal human to make. You don't have to be a superhero to make it. Okay.